In the last few years, open source Postgres has steady on the rise. And if you look at the latest Stack Overflow survey of the most popular databases, Postgres actually leads by a wide margin. And this is because its robust ecosystem of tools, libraries, and extensions, and all this just work out of the box on the Lakebase. And Lakebase can guarantee you single-digit millisecond latency at scale. The second most important part of Lakebase is building on a new novel separation of storage from compute architecture. And it actually has 3 layers to this architecture. At the very bottom, we're using data lakes, or object stores, to store the actual physical data. And object stores are the cheapest storage medium you can find. They're extremely reliable at scale. Now, one of the challenges that Ali actually referred to is that object stores were not exactly designed for the type of workloads that OLTP databases need. 100 millisecond query is plenty fast in the lakehouse for analytics, but 100 milliseconds is actually unacceptable for OLTP workloads. We need single-digit millisecond latency. So the way we've solved that is by introducing a middle layer of storage that's actually only have soft state, and it acts as a write-through cache for all the data to the object stores. And for some of you that are database nerds, it also creates a new way to very quickly persist the write-ahead log, what we typically call as WAL, in the database. And on top of the storage layer, we have the ephemeral compute nodes, which are Postgres instances, that actually reads and writes to the underlying storage layer. One of the things that's very important for me to point out is very similar to lakehouses. The actual data that's stored in the object stores, the data lakes, are open source formats. They're not some proprietary format we invented to actually improve performance or to lock you in. They are just vanilla Postgres pages. And this opens up a whole new sort of paradigm opportunities. And there's actually a lot of past attempts at this problem. This is not the first time, I think, sort of the industry has tried to create separation of storage from compute architecture for OLTP databases. Some commercial systems, especially from hyperscalers, have done that. But they were typically actually built on yet another proprietary storage system. They're way more expensive and also don't use open source formats, which means they can manage to lock you in even more so. The way we crack the code here is actually based on, some of you might recognize the architectural diagram. Say, hey, didn't Databricks actually acquire this company called Neon just last month? And you're already talking to us about it. Now, we did acquire Neon. We announced acquisition last month. We actually only closed the acquisition last week. But one of the interesting things that's not widely known is we actually invested in Neon, the company, many, many years ago, and been working with Neon team as a technology partner on this separation of storage from compute architecture. And everything on Lakebase is actually building on this collaboration. Right? And building on top of this new novel architecture, we managed to accomplish a few fairly interesting things. The first is serverless. And what do we mean by serverless? Well, earlier we said databases are this heavyweight infrastructure that requires a lot of manual maintenance and intervention. Serverless here means database should become lightweight. What does it mean it's lightweight? Well, Lakebase comes in 2 flavors. The first flavor is a provision throughput flavor that it suits you. You actually specify exactly how big you want it to be. If you know how to slice your world, that's the perfect sort of solution for you. But for most people, the auto-scaling flavor will be far more interesting. In the auto-scaling flavor, you don't have to worry about how big a database you should be picking. And because the databases are actually just ephemeral instances, you could only launch it when you need to. It takes less than a second to launch a brand new database. And if you're sort of low scale, you can either vertically scale it, which the system will do it for you, or you can choose to create read replicas that also comes up in less than a second.